Assalamu alaikum guys, welcome back to another lecture of your favorite subject, digital signal and processing. This is Khurram Aziz, and in this lecture we will study these key features. We will study what are systems, their types, what are basic signals, their definitions and their relationships. So system is basically a set of principle or procedure, you can say algorithm, for which if we give an input we get our output, desired output. This desired output in DSP is usually signals. We give input signal, we give an input signal into a system, it applies some algorithm on it and give us our desired output. As you can see, this is the input signal, x of n if you consider, and this is a system, it performs some operations on it, and the output we get y of n. ये जो y of n है हमारे पास, इसने क्या किया बेसिकली x of n के अंदर, x ओरिजिनल सिग्नल के अंदर इसने जो क्या कहते x of n को ऐड किया है और उसके साथ 3 फैक्टर का इंक्रीमेंट डाला है. The next thing is the types of the system that we have, that we will study in this lecture. There are 3 basic types of systems: causal system, linear system, and the third one is time invariant system. First of all, what are causal system? In theory, causal system means a system that outputs depends upon the current and the previous values of the input. For example, let us consider a signal y of n. It has the expression of x of n plus x of n minus 3. Here you can see that x of n is the current value of the signal, input signal, and the x of n minus 1 refers to the past values of the input signal that we have provided to the system. So a non-causal system is the one in which the output depends upon future values of the input. अगर हम एग्जांपल लें तो we will consider that y of n has an expression of x n plus 3. Here we can see that the input signal has some future values in it, the expression has some future values in it, so it is a non-causal system. The next system is a linear system. A system in which the output varies directly with the input is known as a linear system. Linear system holds superposition theorem. For superposition theorem to be verified, it should verify these 2 basic identities: the identity of homogeneity and additivity. The homogeneity property states that if we apply an input to a system which gives us an output y of n, for example if the input is x of n, and we scale the input by k, then we have k x of n we provided to the system, and if the system gives us an output of k y of n, meaning the same scaling is applied to the output, so then it holds the homogeneous property. The additive property is that if we provide a signal x of 1 to a system and it provides us with y of 1, and another system we provide another input x of 2 to a system and it provides y of 2, and if we add these 2 signals, it will provide us the sum of their outputs. So it means that it holds the additive property. This is the basic expression of the superposition theorem. These are the scaling factors which are similar, and the outputs are also the sum. in the terminal expression that we see here. If it does not hold, if the superposition does not hold, if this expression is not satisfied, then the system is nonlinear. The third type of system that we will discuss is time invariant system. A time invariant system has a time dependent system function that is not a direct function of time. It means that it directly doesn't depends upon time. However, it might have an input that might be dependent on time. और इट हैज़ अनदर डेफिनेशन कि अगर इसके अंदर अगर आप आउटपुट के अंदर इनपुट के अंदर कोई डिले इंट्रोड्यूस करवाते हैं एंड इफ़ द सेम डिले इज़ reproduced on the output side, then the system is time invariant. This is the most simpler one. For example, if we have this function y of t is equal to 10x of t, and if we introduce a delay of sigma, then if we get the same delay on the output side as well, that the delay that we introduce on the input side, then this is an time invariant system. On the other hand, the time variant system is the one in which the output changes with time. For example, y of n is equal to x of n square. That ये square जो है हमारे पास ये time के साथ change होता रहेगा. We can give also some abstract example like human vocal track. हमारी जो human speech होती है, it also has some types of ups and down. It can't be constant. ये टाइम के साथ वेरी करती रहती है. द अर्थ थर्मोडायनेमिक रिस्पॉन्स टू टेम्परेचर, थर्मोडायनेमिक रिस्पॉन्स टू सन रेडिएशंस, जो ग्रीन हाउस इफेक्ट वगैरह है, वो भी चेंज होता रहता है. फॉर एग्जांपल द ट्रेजेडी ऑफ द ग्लोबल वार्मिंग इज़ ड्यू टू दिस particular time varying system. The third example that we have is the temperature of our earth. Temperature throughout the whole day. It also varies with respect to time. The mornings are cold and the morning and the evenings are cold, whilst the afternoons are usually hot. Now we will discuss, after discussing the system, now we will discuss the most basic types of signal that upon which the basis of DSP has been laid. The first signal that we will discuss is the unit impulse system. Unit impulse signal, sorry. This signal has a unit magnitude for n is equal to 0 and it has 0 magnitude otherwise. तो ये सिर्फ एक unit impulse. This is the graph that represents unit impulse. The unit step is it has a unit magnitude for n greater than equal to 0 and 0, मतलब 0 से आगे infinity up to so on infinity, it has 1 magnitude. And it has 0 for less than n less than 0. It means there is no response on the negative side. So the basic relation between these two, that if we take integration of the unit impulse, we will get a unit step function, unit step signal, and if we derivate with respect to time a unit step signal, we will have a unit impulse signal. That's all. Hope you like the lecture. Thank you very much.